So here's an example of reversing the order of integration. So I have this double integral here over this region, and I can't really do this inner integral as it stands because e to the x squared doesn't have an elementary antiderivative. So we want to try reversing the order of integration. To do so, we first need to graph the region. So my y here is the outer integral is going from 0 to 1. So I have y is from 0 to 1. And then x here is going from 3y to 3. So over here is 3 and something like this. So this is my region there. And this curve here, I can write x equals 3y, or equivalently, y equals 1/3 x. And the way we write the curves depends on the order of integration. So now I look at this, my x is going from 0 to 3, my y is starting at 0 on the x-axis and going up to 1/3 x. So my double integral now, I have the integral 0 to 3, the x, and y is going from 0 to 1/3 x, and I have an e to the x squared. And now I can easily do this inner integral because now when I look at this guy here, I don't have any y's in my e to the x squared. And so this inner integral here I can work out. My integral 0 to 1/3 x e to the x squared dy. I'm going to have e to the x squared y from 0 to 1/3 x. And so this is going to give me 1/3 x e to the x squared. So now this integral over here on the left, I'm going to have the integral from 0 to 3, 1/3 x e to the x squared dx. And now you can just do a simple substitution. U equals x squared. So we're going to have x dx is going to be 1/2 du. And we're going to come down here now, and we have this now is going to be 1/6 e to the x squared from 0 to 3. So we have 1/6 e to the 9 minus 1/6 e to the 0. E to the 0 is 1, so I'm going to have 1/6 e to the 9 minus 1/6, and that's my final answer.